So our next talk will be Christine Staiger. Is that good? From SURFsara also, a national approach for storage scale-out scenarios based on iRODS.
Thank you. In the morning session, you have already heard from Frank which path we are going to go. It's always good to have very high ambitions. But in the past month, Ton Smele, Rob van Schip, and we were busy setting the first steps on that path. And that is basically providing national storage in an iRODS compliant way to university iRODS storage systems. So I think you have already seen a lot of context. Yesterday we saw very nice implementations of iRODS systems taking part or caring for data management at the universities. And we from SURF, we thought, okay, at some point these iRODS systems grow. They grow with the number of users, they grow with the number of projects, and thus the amount of data. And we at SURFsara, we have storage systems available for our users. So in this proof of concept, we are busy with, or we dealt with the problem, how can we provide these storage systems in an iRODS compliant way so that it integrates smoothly with existing storage systems. We concentrated on two scenarios. One is for data replication. In that scenario, data resides primarily at the university and users can work on their data at the iRODS instance at the university. And there's a copy of that data in one of the SURFsara storage systems for archiving purposes. For example, in a permanent storage for disaster recovery. Or there is also the variation that you can have just short-lived copies of that data on an infrastructure that is tightly integrated with compute infrastructure. The other scenario that we focused on is a real storage scale-out. So there, SURFsara storage serves as as the only storage system where the data lives. And the users work directly on that data from their home PC or from their lab via the iRODS instance hosted at the university. And this is actually the use case that is most demanding in terms of performance. So in all of our tests, we concentrated on that scenario because archiving will come then for free after that. That is our technical setup. As I said, do I have a, wait, yep. So we have here the university's iRODS ICAT enabled instances. And at SURFsara we have a lot of different storage systems. We have Ceph storage that is tightly integrated into our HPC cloud. We have a separate Swift storage cluster. We have 2 tape environments. And we have spinning disk storage available for our users. The scope of the proof of concept was how can we provide these storage systems to an iRODS ICAT-enabled instance. And the route that we took was we are leveraging on the principle of iRODS resource servers. We host iRODS resource services at the moment in our HPC cloud environment, which is not the optimal environment for a stable service, but for proof of concept, very valid. And via this resource server, universities can make the connection to the single storage systems, and they have the full command over the storage systems as far as their account goes on there. So the data that lives then in these storage systems is managed by their iRODS rules. So our questions in the proof of concept was, is this actually feasible? Can we provide all of our storage systems in a fashionable way? How much effort does it cost from SURFsara? And how much effort actually costed the universities? Because there is some setup involved. And can we abstract from that and provide patterns? For the implementation, we again just relied heavily on the iRODS way of implementing storage systems or attaching storage systems. We have what I called here, I'm not sure if that's the correct term, but first order resources in iRODS. So these are storage systems that can be provided to the machine where iRODS runs on in a POSIX compliant way. And for all other storage systems, we are relying on the compound resource. We saw that in the tutorial. There you have a cache resource, which is a POSIX-compliant storage system attached to iRODS, for example, as a Unix file system resource. And then you have the archive resource. And for example, for our Swift cluster, we can use the S3 plugin that iRODS provides. We also provide an implementation using the Python Swift client. And for our archive environment, we provide a bridge using Grid FTP. In the testing scenarios, we will focus actually on our Ceph storage system, because this is basically, well, you need the cache resource, and the cache resource in that setup is based on Ceph. Sorry. And so for the user, it plays a role how fast data is going to the iRODS system, and the handling in the back end, well, it should be taken care of by the iRODS system, and that is something that we did not test yet, because we are not on a real infrastructure. We are just in a proof of concept phase. So from the setup, we found, well, we can actually offer all storage systems at SURFsara in such a way. We can provide the universal mass storage driver scripts, and we offer tutorials how to customize them and leverage on them to make the connection between the cache and the archive resource more efficient. As I said, we tested the Ceph resource with respect to usability. If you remember, I told you that we had two scenarios in case. One was an archival scenario, which we will just leave out for the moment. But we focused very much on, is the system usable for a scientist? So we tested usability from a general workstation located here at the University of Utrecht. That is, well, that can make a connection via DAF-RODS to the resource server, but also with the I-commands. And we actually tested these resource servers with respect to the performance from our compute servers at SURFsara. As I said, out of scope, we're at the moment the testing of the connection between cache and archive resource, because for that we need real infrastructure. That is our testing scenario. So we tested from a user's workstation. The user ingests data with DAF-RODS to the ICAT-enabled database, but specifying that the data should ultimately go to the resource server. And then there are two routes that DAF-RODS take. Bigger files are directly transferred via DAF-RODS to the resource server. DAF-RODS works here as a proxy. And smaller files go through the ICAT-enabled server to the resource server. And actually for the I-commands, it's pretty much the same, just that the I-commands reside not on the server side, but on the client side. So larger files are directly ingested to the resource server. Smaller files go the same route via the ICAT-enabled server. Yeah. We tested the DAF-RODS running Office applications, like opening spreadsheets, PDFs, Word documents. And for the programmatic access with the I-commands, we tested a set of ping-ponging data between the iRODS server of several sizes and folders of several sizes. So for the Office workflows, we had a tester who provided us with his experience. That was Rob. Thank you. We found that actually opening ASCII files, PDF files, spreadsheets, and even manipulating and storing ASCII files and spreadsheets are just slightly slower than when you would work directly on your computer. But everything was well, opening and writing was less than, I think, 2 or 3 seconds. So for a real user, he hardly noticed any differences. We also tested different workstations. We had a Windows workstation and a Linux workstation, and there were no major differences in performance. The only thing that we found is that when you connect from a Windows machine to the iRODS server for the very first time, you can wait sometimes for half a minute. And this has something to do with the Windows authentication. Then we went on testing the iCommands from a workstation, this time a Linux workstation. And as I said, we tested several files. We had a 100 megabyte file, 1 gigabyte, 2 gigabyte, and 5 gigabyte files, and ping-ponging them between the iRODS server and the workstation for about, well, I think in that case 20 times. I measured it here in gigabytes per second, and for the real user, it translates to that for a 5 gigabyte file, it gets transferred within 25 seconds. And these are averages, what I show here. We saw a huge performance drop when we transferred a folder with 100 times 10 megabyte files. And this has something to do with, we used IPUT -R, so recursive, but we did not tell iRODS that it's a bunch or bulk operation. So iRODS tried to reconnect for each file, leading to a lot of overhead. So that's one thing. The other thing is, these files are all 10 megabyte files. So they go via the control port and not via the data ports. So there is something to gain in that scenario. We did the same iCommands testing from our two national computers, high-performance computer. We have a national compute cluster and a national supercomputer. We see with the iCommands, so the drop here is exactly the same. And otherwise, when you look at the performances for the Orange, which is our supercomputer, it performs as well, the performance is as good as when you're coming from outside of the SURFsara network. And this has something to do that the national supercomputer is very much optimized towards that the nodes can efficiently communicate with each other and not so much to the outside world. So it's not optimized for I/O performance on a normal worker node. We have special data staging nodes for that. For our national compute cluster, it looks very different. So this one is really tuned towards input-output performance for our users. So wrapping up some other findings, 5 minutes, good. We found that network configurations play a huge role when you want to scale out to a third-party storage provider. For some reason, the iRODS ICAT-enabled server was hidden behind a load balancer, shielding all the data ports from the outside network. And so connections or data transfers for large data were not possible from outside. So this is something that we should really have to take into account when we want to set up such a thing as a national infrastructure. If you are dealing with sensitive data, I think at the moment we can think of special network setups, but if you go to the iRODS setup, you have to go to a federation. So you have one iRODS server talking to the outside world and another one in your local network. We also found that well, the concept of compound resources is very powerful. You can basically attach any storage system or accounts or whatever to iRODS, but they certainly need careful setup because they are depending very much on the composition of the cache and archive resource and how you employ them in your daily life. So basically the cache has to be as big as the largest data file that you will ever ingest into the archive, which makes it sometimes difficult to cater for certain use cases. And well, you need extra monitoring to prevent cache overflows. So even there, if you think of a role definition between a community running iRODS and the storage provider, this is also something to have a look at and needs careful definition. And actually, it has also impact on the policy, because a data user, well, he can always assume that when something is in cache, it is safely written, but is it really safely written to the archive resource? So, summary. Performances and user experiences look very acceptable, actually. So we were quite happy about that. We have to have a look at the limited network configurations and come up with some smart concepts and designs for sensitive data. At the moment, we were in a proof of concept state, so we did not do the real performance and stress testing, and this is something for the next period. We need to test actually the throughput from the cache resource to different archive resources. We need real-life test settings, so what happens if 100 users connect to the iRODS resource server, which is a very small virtual machine, via the ICAT-enabled iRODS server. And another thing to think about, and what we are doing in parallel, is how can we enrich the setup with iRODS federations? When should data go to a different federated zone, so to a different administrative domain? And when can you use the scale-out scenario? And with that, I would like to thank you. And do you have any questions?
Hey, I have a quick question. When it comes up to the ICATs that you've defined, were they intended to sit at universities physically, or were they intended to be provided by the SURFsara with the...
Okay. So in that setup, we tested how does the system behave when the ICAT-enabled servers are sitting at the universities, but we are also preparing for the scenario that we also host the ICAT-enabled server. For long term, we also plan to host the iRODS ICAT-enabled server completely, but at the moment we would like to leave that to the universities. And they decide where to put the ICAT.
Have you been thinking about how to share the administrative burden in the case the iRODS ICATs would be sitting at the university, considering which admin privileges would be given to the university, and how much would you guys interact with these?
Okay, for the very first stage, everything that is concerning the ICAT server and the iRODS resource server lies with the universities. The hosting of the infrastructure, the virtual machine, for example, and the connection to the storage that we provide lies with SURFsara. So this is basically, you cut it in, the universities are the iRODS admin, and we are the sysadmin on the virtual machine.
Okay. Thanks.
Thank you so much.